All right, today we're going to tackle three of the biggest buzzwords in tech: artificial intelligence, machine learning, and deep learning. You hear these terms thrown around all the time, right? And a lot of times, they're used interchangeably. But as you're about to see, they're actually distinct ideas that fit together like nesting dolls.
So let's just dive right in with the one question that really kicked this whole thing off. Can a machine actually think? I mean, it's a simple question, but it's also incredibly profound, and it's been the driving force behind decades and decades of research, pushing scientists to build systems that can reason and learn in ways we normally only associate with us humans.
To try and answer that big question, the legendary Alan Turing came up with a test. Imagine this. You're sitting in a room and you're having a text conversation with two others you can't see. One is a person and the other is a machine. If you chat with both of them and you can't figure out which one is the machine, well, then that machine has passed the Turing test. It's become the classic benchmark for what we'd call machine intelligence.
So where do you even start if you want to build a machine that could actually pass a test like that? Well, the whole journey begins with the biggest, broadest concept of them all: artificial intelligence.
So what exactly is it? I think this definition really nails it. AI is the whole huge field dedicated to making machines smart. It's the entire effort to build systems that can do things that, if a person were doing them, would definitely require some intelligence. Just think of AI as the big umbrella that covers everything else.
Let's picture it like this, okay? AI is this giant circle. It represents the entire universe of trying to simulate human intelligence in a machine, a quest we've been on since way back in the 1950s. But how we've tried to get there, well, that has changed. A lot.
And this slide right here shows the massive shift in thinking. The old school way, what you might call traditional AI, was all about rules. I mean, humans would literally sit there and write thousands and thousands of if this, then that rules to try and code knowledge into a machine. But that approach is super fragile. The modern way, machine learning, flips that completely on its head. Instead of giving the machine rules, we just give it a ton of data and let it figure out the patterns for itself.
And that leads us perfectly into our next layer down, machine learning. This isn't just a part of AI. For all practical purposes, it's the engine that is driving almost every single AI breakthrough you hear about today.
So if you look at our diagram, machine learning is this big circle that sits right inside of AI. It's a specific way of trying to achieve artificial intelligence. Instead of trying to program intelligence in by hand, we build systems that can learn from experience.
Okay. So how does it learn? Well, as AI pioneer Andrew Ng points out here, almost all of it is through something called supervised learning. Now that sounds technical, but all it really means is that we show the machine a massive number of examples that we've already labeled. We show it 10,000 pictures labeled cat and 10,000 labeled dog, and after seeing enough examples, it starts to figure out how to tell the difference on its own. It's all about learning from data we've already labeled.
Now we're getting to the really exciting stuff. Let's drill down one level deeper to the most powerful and modern technique in this whole field: deep learning.
And there it is, the very center of our diagram. Deep learning is a specialized and incredibly powerful type of machine learning. It's a subset of a subset. So you've got this nested relationship. All deep learning is a form of machine learning, and all machine learning is a form of AI.
That's the key question, isn't it? What's the deal with the word deep? It sounds super complicated, but the core idea is actually pretty elegant. What exactly is the deep part of deep learning?
Well, the deep part just refers to the number of layers in something called a neural network. It works like this. Data, like all the pixels in a picture, goes into the first layer, the input layer. Then it gets passed through multiple hidden layers. Each layer recognizes more and more complex features. So the first layer might spot simple edges, the next one recognizes shapes, the one after that sees objects. Finally, an answer pops out of the last layer, the output layer, saying cat or dog. The more of those hidden layers you have, the deeper the network is.
And these incredible, layered structures are called artificial neural networks. And yeah, just like the name says, their design is loosely inspired by the network of neurons in our own brains. This is the basic architecture that makes all of deep learning possible.
And the results you can get from this deep, layered learning can be absolutely mind-blowing. Take AlphaZero, for example. Researchers gave it nothing but the rules of chess. That's it. By playing against itself millions of times, a process powered by deep learning, it taught itself to become the best chess player in the world. And it did it in just one day. Better than any human, better than any other computer.
Okay, that was a lot to take in. So let's just take a quick step back and recap this whole AI family tree one more time so it really sticks.
So here it is, the big takeaway. This relationship is everything. Think of it like this. AI is the overall goal, the big ambition of creating intelligent machines. Machine learning is a specific method to achieve that goal by learning from data. And deep learning is the cutting-edge technique, a powerful type of machine learning that uses those deep neural networks. They aren't three different things. They're concepts nested one inside the other.
So why should any of this matter to you? Because this isn't science fiction anymore. This tech is all around us right now. It's powering robotics, it's behind the natural language processing in your smart assistant, it's being used for advanced medical diagnoses, and it's the core technology that's making self-driving cars a reality. This stuff is literally shaping our future.
Which leaves us with one last fascinating thought to chew on. Remember AlphaZero, the unbeatable chess AI? Well, here's the thing. It can't explain its revolutionary strategies to us. It can't tell us why it makes the moves it does. So, if a machine can perform at a superhuman level but can't explain its thinking in a human-like way, has it truly passed the test of intelligence? It's something to think about.